Welcome to this tutorial on how to use the Adaptive Evolution Database, or TAED. Today I will be discussing how to use TreeThrasher and how TreeThrasher can be used to access TAED data. To begin, select the link for TreeThrasher. TreeThrasher is a standalone program designed to display large phylogenetic trees. It is a three-dimensional tree viewer and allows for the exploration of large phylogenetic space. It has been tested in Windows XP, Windows 2000, Windows 7, and Windows Vista. To download the program, simply click the link to download the executable and save it to your computer. The TreeThrasher manual, which contains additional information, can also be viewed by selecting this link here. Additionally, frequently asked questions about TreeThrasher can also be viewed right here. To use TreeThrasher in association with TAED, it is useful to first download additional files generated from TAED data. To do so, select the link Tree of Life. Here, there are two downloadable files, one for all protein families and one for only DNDS ratios greater than 1. The first file contains the chordate species tree with protein families mapped to each branch within the chordate species tree. The second file is very similar, except it contains mappings of only lineages with a DNDS greater than 1 to each associated lineage within the chordate species tree. Both of these files are in NHX format and are designed to run within TreeThrasher. TreeThrasher will display both NHX formatted trees, which are used within TAED, and regularly formatted Newick phylogenetic trees. To begin, let's open up our version of TreeThrasher. Once TreeThrasher is open, I will begin by first opening up the file enhanced chordate species tree.newick. This is the file generated from TAED data. You may navigate through the tree by selecting nodes within the viewing area. By selecting nodes, the tree will auto-increment throughout the tree. One key feature of TreeThrasher is that as the tree is rotated manually or automatically by the user or the program, that by double-clicking on the node will cause auto-orientation of the complete tree. What this means is that the parents to the node will always be on the left-hand side and the children will always be on the right-hand side. The current tree that's being displayed is taken directly from the NCBI taxonomy browser. This is the taxonomy that was used for generating TAED data. Some key features useful to know when using TreeThrasher are first, that it is possible to select and increase the width of each line within the program by simply selecting the line button here. Additionally, it is possible to find a node by clicking the Find button. Here I will find the node for Mammalia, and I am directly taken to that node within the tree. At times, navigating through the large phylogenetic trees can be disorienting. It is useful sometimes to make a path showing how to get from one node to another. Here I will tag Mammalia as the left end or the right end of my path using this button here. I will then go back to the beginning of the chordate tree and I will tag this as my left end. Then I will select Path, and it will show me the path through my tree to my other end. This is useful when navigating large trees such as the chordate species tree, which contains over 50,000 different taxa. Furthermore, as I previously stated, it is possible to rotate the tree in any orientation that the user desires by simply right-clicking on their mouse and moving the tree. Left-click and moving will move the tree in a complete pattern as such. And again, to reorient the tree, simply select a node. The center button will additionally go back to the origin of the tree. When using TreeThrasher to access TAED data, one may simply select a node of interest and click on it. Here I have selected the node for Amniota. To the left of the node, on the lineage leading to Amniota, we see a number, 6036. This is the number of lineages within TAED that mapped to the lineage Amniota. To further explore those gene families, one may simply select the TAED button located at the top of the TreeThrasher menu. By selecting this button, a website will open up and a portal to the TAED database will be generated. Here, I may further refine my search by displaying all families that have a lineage leading to Amniota, display all protein families with DNDS ratios greater than 1 that are along the lineage for Amniota, or display all protein families that had a duplication event that occurred along this same lineage. Here I will display all protein families with the DNDS ratio greater than 1, and I will select Search TAED. This will generate a list of all of the protein families that have a DNDS ratio greater than 1 along this lineage. And we may further explore those protein families. Next, I will demonstrate how TreeThrasher can be used to view TAED tree files. Here I will open up my browser to the TAED website, specifically to the TAED search engine. I will search for a gene name, D-aspartate. I will search TAED, and here I see that my top hit is for D-aspartate oxidase. I will download the NHX version for this gene family. Entering into TreeThrasher, I am then able to open a new file and find the file that I just downloaded. And here we see displayed the NHX version of this gene family. As I highlight nodes within the gene tree, information displays on the corresponding lineage leading to that node. Here we can see on this node that the DNDS value is 0.325 and the type is S, indicating that it is a speciation event. The node number, where it says BSV101, is indicative of the bootstrap value for that given node. Species names are indicated at the tips of the node and are also displayed in a box. This concludes this tutorial about TreeThrasher and how it relates to TAED. For more information on TreeThrasher, please consult the TreeThrasher manual. Additionally, it is important to remember that TreeThrasher is also useful for other regularly formatted Newick phylogenetic trees, and we'll be able to display those. Thank you.